Good morning. Today we will be presenting our Economics and Design project for part 1 and part 2. This project focuses on ergonomic evaluation of three workstations in FTKIP workshop, which is welding workstation, sandcasting workstation, and cutter machine workstation. The aim of this project is to identify ergonomic issues faced by users and propose design improvements that can enhance the safety, comfort, and overall work performance. Throughout this presentation, we will discuss our analysis, findings, and proposed workstation designs. Okay, hello everyone. This project focuses on ergonomic evaluation and workstation redesign in FTKIP workshop. So as you can see, ergonomic focuses on improving the interaction between users and their workstation, right? And poor workstation design can lead to discomfort, fatigue, reduced productivity, and musculoskeletal disorders, right? So there are three workstations were selected, namely for this project, which is welding workstation, sandcasting, and metal cutter workstation. The existing design were analyzed using observation, digital modeling, REBA, ruler, and the user surveys. Based on the identified economics issues, improved workstation designs were proposed to improve user comfort, safety, and productivity.
So now I'm going to talk about the welding station in UTeM FTKIP. So firstly, we have done some direct observation on the user of the welding station, and you can see that this is the first year degree student in FTKIP. So we have interviewed them during their workshop session, and they are facing excessive back flex during welding, and they are difficult to control the electrode holder during welding. Also, they are facing some balance and stability issue. Lastly, they need to maintain static wrist bending in prolonged period. So based on the problem statement and need requirements, the design requirements is also listed as below. So for the excessive backflex, we are suggested an angle table surface and adjustable table height. And then because of they are difficult to control the electrode holder, so we need to reduce the grip demand. So we have suggested contoured rubber grips handle with finger indentation. And then the third one is they are facing some balance and stability issue. So they will have an arm support for the dominant hand. And then lastly, because they need to maintain static wrist bending in prolonged period, so we propose an angle electrode holder. So this is the before and after improvement of the welding table. So based on the design requirements, we make a clank link to the adjusting mechanism of the table. So when the user push the lever, the table will become higher and vice versa. And then we also put an arm support on the right hand side of the table because most of the user have their right hand side as the dominant hand. So we put it on the right hand side to maintain the stability. And then because they need to bend their back and neck in a prolonged period during welding, so we also use an angle table surface. And then this is the electrode holder design before and after improvement. So firstly, we'll see an angle head for the electrode holder. This is because to prevent their wrist twisting during welding. And then you can see on the handle side, we are using a rubber grip with finger indentation. So this will give a clue to the user that which angle that the finger need to hold on the hand on the electrode holder, and also to give a better grip. And then this is the before and after improvement design of the welding table with a mannequin. So you can see that from the side view of the workstation, so the back flex is actually reduced a lot because of the angle table surface and the adjustable table height. And then because of the arm support, so the stability of the user is also increased a lot. This is the electrode holder before and after improvement. And this is the simulation on Blender. So you can see that although they are using the same welding angle, but after improvement, the mannequin actually doesn't even need to twist the wrist. So the wrist twisting angle is actually reduced significantly. And also because we have enlarged the diameter of the holder, and also we are using rubber grip and finger indentation, so they are also a significantly better grip on the electrode holder. So they are also um, have a better control on the electrode holder.
Good day, everyone. Today I am presenting our ergonomic analysis and a redesign of sandcasting workstation at our FTKIP workshop. Our initial evaluation of the existing workstation revealed several critical issues. As you can see from the photos and our 3D model, the entire process is conducted at floor level. This is a major design flaw. It forced students into extreme non-neutral postures, especially deep transflexion of over 60 degrees just to reach the mold box. When we combine this with the non-adjustable 15 centimeter wooden stool, the result was a critical risk level, a REBA score of 11. Students are essentially squatting and kneeling, which put several strain on the lower back, neck, and legs. Furthermore, the workstation is tightly confined by nearby storage locker, leaving almost zero clearance for movement. Perhaps most concerning is the safety hazard. Pouring molten metal from the unstable low-seated position significantly increase the risk of catastrophic burns the spill. To address these failures, we developed an anthropometrically optimized design. The primary improvement is revealed working platform which bring the mold blocks to desk height. This allows students to work in neutral standing or seated posture, eliminating the dangerous transflexion we saw earlier. We replaced the inadequate wooden stool with an ergonomic height adjustable chair that provides proper lumbar support. We also open up the same frame structure underneath the desk, finally providing the necessary leg and foot clearance for comfortable operation. To improve efficiency, we recognize the layout into a dedicated zone for mold preparation and tool storage, which minimize unnecessary reaching. Finally, we redesign the ladle with ergonomic handle for better pouring, control, and safety, and improve the operator's line for sight to reduce the neck strain. In conclusion, we have transformed a high-risk floor-level workstation into user-centered environment. The data speak itself. Our redesign is engineered to lower REBA risk of for a dangerous level down to an acceptable level of less than 3. By correcting these systematic design faults, we are not just improving comfort. We are creating a safer, more productive learning environment that prevents long-term musculoskeletal disorder and minimize the risk of workshop accident.
Good morning, everyone. For my part of this project, I selected the cut-off machine as the area for improvement. The cut-off machine is located at our FKP workshop and it's commonly used for cutting metal materials. So during our observation, we found that the cutting machine position creates ergonomic issues for users because it is placed at a floor level. Therefore, our proposed improvement is to place the cut-off machine on a hydraulic jacking table so the working height can be adjusted a more ergonomic and comfortable level for the operator. So this slide shows the existing cut-off machine currently used in our FKP workshop. So from our observation, the machine is placed directly on the floor. Because it is low height, the user needs to bend their back and neck while setting up the material and operating the machine. So in some situation, the user may also need to squat or kneel down. This awkward walking posture can be cause discomfort, especially at the lower back, shoulders, arms and knees and legs. So during cutting activities, the user also need to apply some forces while remaining in a bend position. This increases physical fatigue and can reduce comfort during longer working sessions. Based on our ergonomic efficiency assessment, the working posture is rated as poor, while physical fatigue is rated as high, and reach distance and comfort and ease of operation are only at a moderate level. So therefore, the main ergonomic problem is in the low machine height, which forces the operator to work in uncomfortable and unsafe posture. So for the purpose design, the cutoff machine is placed on the hydraulic jacking table. So the purpose of this table is to raise the machine from floor level to a more suitable working height. Since the table is hydraulically operated, so the height can be adjusted depending on the user's comfort and their type of work being performed. So with this improvement, the operator can perform cutting activities in a more upstanding posture. The user no longer needs to be bent excessively, so squat or kneel on the floor while operating the machine. So this helps to reduce unnecessary physical effort and reduce pressure on the lower back, neck, knee, hips, and legs. So it also improve the operator's balance, comfort, and ability to work for a longer period without become fatigued too quickly. So, in short, the hydraulic jack does not change the function of the cutoff machine. Instead, it improves the working height and ergonomic condition of the operator. So, the slide compares the existing design and the proposed design. So, on the left side, we can see the existing condition. So the operator is kneeling and bending forehead because the cutoff machine is positioned at the floor level. The posture creates high stress on the body, especially on the back, knees, and shoulder. On the right side, the proposed design allows the operator to stand upright while operating the machine, which is the upright posture body. The machine is lifted by the hydraulic jacking tables for more appropriate level. So the ruler assessment, which is the Katya's software, one of the ruler assessment, so also shows an improvement. The existing workstation is has a higher ergonomic risk score, while the proposed adjustable workstation has a lower score. So this indicates that the redesigned workstation provides a better working posture and reduce the risk of musculoskeletal discomfort. So therefore, the proposed hydraulic jacking table creates a safer, more comfortable, and more ergonomic working environment for students in the workshop. So, in this, we make a conclusion that the existing cutoff machine creates a ergonomic problem because it is placed too low on the floor. So, by using the hydraulic jacking table, the height of the machine can be adjusted to suit the user. So, this improvement, we know that the improvement reduce the bending, squatting, and the physical fatigue while improving comfort, posture, and safety during operation. So thank you.
So, in conclusion, the existing workstation contains several ergonomic issues that may negatively affect the user health and the performance. Through the ergonomic analysis and digital human modeling, the key risk factors were identified, such as the awkward postures, excessive bending, kneeling, and limited workspace clearance. The sandcasting workstation recorded a HREBA of 11, indicating a very economic risk. And the user survey results also showed high levels of discomfort, especially in lower back, knees, and legs, and all that. So, the proposed improvement successfully addresses these issues by improving the postures, safety, comfort, and operational efficiency. Therefore, the redesigned workstations provide a better ergonomic solution for FTKIP workshop users. And that's all from us. Thank you, everyone.